In the prior section, we had looked at managing vSphere virtual machines in an advanced manner, and in this section we are going to cover managing vSphere 6 advanced storage. In this section, we are going to take a look at pluggable storage architecture, the PSA. This is the way that ESXi is able to handle device drivers and to be able to use the storage array's capabilities to the maximum. We will look at configuring NFS 4.1 data stores, and we'll do this in great detail. We will concentrate not just on the ESXi side of things. We will also look at the NFS 4.1 server and the steps one has to go through for a typical Linux-based NFS server to actually set up an NFS 4.1 share. We will then look at configuring iSCSI data stores. We will again look at this in great detail. We will look at again not just the ESXi side of things, but we will also look at the storage array. Luckily, I have a storage array that is reasonably easy to manage and allows us to create LUNs, and I have plenty of storage available, so we will be able to create LUNs, and then you can see how we can actually pick them up on the ESXi side of the house. A key aspect is LUN masking. We will look at the whats and whys of LUN masking, and we will look at LUN masking on the storage array, and we will look at LUN masking on ESXi. This is a key technique that one has to always have in one's toolbox. We will look at a couple of tools after this. One is the vSCSI stats tool, and the other is the VMKFS tools. Both tools are relatively unknown nowadays because storage arrays have become very sophisticated, and in some cases it doesn't really make sense to do it like this. But there are times when the GUI way of doing things, so using the graphical user interface of, say, the web client, there are times when the information that you need is not readily available through that, or in some cases just doesn't work because things are really in bad shape out in the storage, in which case you can go in with the VMKFS tools, for example, and be able to manipulate partitions, manipulate VMFS file systems, as well as VMDK virtual disks. vSCSI stats is a terrific tool as well. Again, in the days of spinning disk, this used to be much more useful now. Modern storage arrays actually manipulate where the data is stored, so it may not work all the time, but I'm sure that. So with that, we are now going to go to the next video, which is pluggable storage architecture. In this video, we are going to look at pluggable storage architecture, also known as the PSA. We are going to take a look at the actual PSA itself and describe the various functions that it performs, as well as the various aspects of it, including what the various plugins are. We will then look to move to the ESXi command line and look at ESXi storage one more time with the command line tools, because we need to become really proficient with it. And once we have a reasonable understanding of what it looks like on the command line and how one can actually visualize the ESXi storage there, it's then time to explore the advanced storage management capabilities of the PSA with command line tools. We will go into some great detail about SATPs and PSPs, as well as being able to change the IOPS limit and so on using the actual command line. Pluggable storage architecture was introduced in vSphere 4.0. It is basically a set of APIs so that the third-party storage vendors that are introducing new capabilities in their storage products could actually interface with ESXi. And the areas where there was the most progress being made at that point in time was in the multipathing of those arrays. So in order for vSphere to be able to utilize to the max the multipathing capabilities of storage arrays, which were done differently by different storage vendors, this set of APIs really came in handy. Because before vSphere 4, the only options one had for multipathing was the fixed, or the most recently used, also known as the MRU. So by having this set of API, you could actually just plug in a MPP, a multipathing plugin from a third-party storage vendor, and that would plug into this pluggable storage architecture and provide the capabilities that the storage vendor had just introduced. The PSA discovers available storage, and it also determines the physical paths to the storage. Once it has done that, using something called claim rules, and we'll be looking at claim rules very extensively, paths are actually claimed, and the PSA then assigns, based on those claim rules, it assigns the multipathing plugin to actually use. So MPP is the multipathing plugin, NMP is the VMware's native multipathing plugin. So in those cases where there is no specific multipathing plugin for the storage array, the VMware native multipathing plugin is the default, and that actually then takes over the management of that storage array, or actually the transfer of data back and forth to the storage array. In order to do this, there are two other plugins. One is called the SATP, which is the storage array type plugin. And the reason this is required is because storage types have different capabilities. Some are asymmetrical logical unit access, some are active-active, some are not, and some other capabilities too. So basically the SATP determines the type of storage array that is being accessed. And when that's done, we can then plug in the path selection plugin, so that if multiple paths are available, what kind of path selection policy to actually utilize for that data traffic is then determined by the PSP. So it could be the most recently used, it could be a round robin, or it could be a fixed policy, or something else, something maybe much more sophisticated that the storage vendor can then provide as a PSP. So I'm now logged in into my server. It's the 192.168.0.201 server that I've been using in this course. Let's look at some storage commands. ESX CLI storage core device list. As you can see, there are quite a few of these devices out there, so we will pipe it through more. And we can then take a look at the NAA, or the canonical name of that device, the display name. I have a Synology server basically, so it's and I'm using it for iSCSI, so there's an iSCSI disk. The multipath plugin, we just talked about that. It's being claimed by the NMP, the native multipathing plugin. This is the actual path to that device, so /vmfs/devices/disks, and then the actual name there. The vendor is Synology. There's a model here as well. Now some of these things like the model and the vendor can actually be used to learn masking, but we'll just hold that for later. Right now, just focus on the fact that the vendor and the model can be actually accessed for your devices by using this command. Let's keep going forward. RDM, we tend to not use it at all nowadays. It's not an SSD. It is not a vVol. That's the virtual volumes PE. It's not offline, which means it's online. And this is another key one. VAAI status is supported, so VMware's API for array integration. Its primitives are actually available, so one can do thin provisioning and so on when we define the various data stores. The RAID level is unknown. I'm just using JBards, and the other ones, let's not worry too much about them. Okay, so we have seen that using ESX storage core device list and piping it to more, one can obtain the various devices that are available. Now let's look at ESX CLI storage core adapter list. This should obviously list the adapters for us, and we will pipe it to more just to be on the safe side. Okay, and as you can see, there are two adapters out there. One is the VM HBA 0 that has the MegaRAID_SAS driver, and here's some more information about it. It's the MegaRAID SAS controller. And then we have VM HBA33, which is the software SCSI driver, which is the name of it is iSCSI_VMK. It is online, and this is its iSCSI qualified name, basically like a worldwide name essentially for this HBA. And this is a convention that's followed after the IQN. 1998-01 means January of 1998, which is when VMware.com was actually used for this, and then there is a string after the colon, which is derived basically from the host name and some other aspects of the ESXi host, so that you would have a unique IQN that is then created. So I'm going to clear the screen now. We have just seen how we can look at devices and adapters. Clear the screen, and let's look at cd/vmfs to an ls. As you can see, in this directory there are devices and volumes. Let's cd to volumes and just list the volumes. As you can see, your data stores are out here. We can do an ls. Here we are. Some of these are basically links. As you can see, this is a link to that, and 200G -B is a link there. So some of them are links, but these are the ones that we can actually also obviously utilize. So what we are learning here is that ESXi basically mounts the devices here at /vmfs/volumes, and we can refer to these volumes by, for example, with datastore-200G-A, we can refer to it as /vmfs/volumes/datastore-200G-A. And in fact, let's do that. So let's do an ls on /vmfs/volumes/ I'll key this in, data store-200G-A. And as you can see, there's a folder in there as well, which is an Ubuntu virtual machine that I use for DRS storage. Okay, so volumes or your data stores are found in /vmfs/volumes. Let's clear this. Let's cd back there and cd/vmfs/devices. What we see up here are many things which are basically our devices up there, but the ones that we are looking for are disks. So cd disks, and we do a /device/disk, and basically what we have up here are again the various devices that we have here. So these are the canonical names of the various devices that the ESXi host is actually seeing. So /vmfs/devices/disks is gives you all the disks that are available, and /vmfs/volumes directory has basically your data stores. So with that out of the way, let's now look at some other storage commands, and these are more to do with the PSA. So we will talk about the PSP, which is the plugin, path selection plugin, and then we'll talk about the SATPs as well, which is a storage array type plugin. So the commands for that are basically here: ESX CLI storage. Instead of using the core namespace that we were using before, now we'll use the native multipathing. NMP PSP, list the PSPs here, and as you can see, they have a certain name and they follow this convention. So the most recently used path selection PSP is called VMW_PSP_MRU, all in caps. RR with the same prefix of VMW PSP is the round robin path selection, and that is the fix. So there are basically 3 PSPs that are available for this native multipathing plugin. Now let's look at ESX CLI storage NMP SATP list. We are now listing out our storage array type plugins, and obviously there are many more of these. Now let's just look at some of them. So the again, first of all, you'll notice that the prefix of all the SATPs is basically VMware_SATP_ all in caps, and then after that comes the actual type or the more specific designator there. So ALUA is the asymmetric logical unit access, which means that there is a preferred path or an optimized path and a non-optimized path to the LUNs. and it supports basically, as it says here, any basically array that uses a Lua. There are still many arrays that use a Lua. Now, every one of these SATPs has a default PSP. So if it's an Lua kind of array, its default PSP is the most recently used. So basically the idea is that if there is one optimized path, you select that optimized path and throw all your IO down that path, and just keep basically using it. If that fails and it goes over to the non-optimized path, well, in that case, the non-optimized path will just keep on being used. And again, as even if the other path comes up, the more optimized path comes back up again, the MRU will keep you on the non-optimized path. So it's a very basic way of actually working, and not really optimal. So this is something you need to watch out for if you have an Lua kind of an array. This one, the VMware SATP SVC, is for the IBM SVC storage arrays. Interestingly enough, its default PSP is actually fixed, so it just stays down on 1 until it fails, and then it switches over to the next one, next path rather, which is available, and then stays there. This is for Ecologic. Here is for the EMC CX, ENC Symmetrics. This is CX Lua. This is just the CX. As you can see, it's interesting, the Lua CX, the default PSP is actually round robin. So what this means is that for any one of those CX arrays, again, these are very old arrays, and for these arrays, if this is the SATP that's actually used, then the default PSP or the path selection is actually round robin. So it after a certain number of bytes have actually gone down one path, then or the certain number of IOPS that have been done on one path, then it switches over to a different path. And we look at these IOPS and number of bytes and how to manipulate that pretty soon. So this, of course, is a symmetrics. This is for LSI. Here is the default SATP for active, which again is interesting, because if your paths are active, the default PSP says, let's just go down one path and just stay on that path. Well, my point is, well, if it's active, why should we not utilize both or more than one of those paths which are actually available? So again, you are able to, and we will look at that very shortly, how one can actually change the PSP, the default PSP that is associated with a given SATP. So having looked at that, let's look at a few other commands. First of all, I need to find a few disks. So we are at dev disks, so I can do an ls, and I have the disk there. I am going to select this device, ESX CLI storage NMP PSP generic device config get dash device, and I right click for my array and I hit the enter key. Okay, so for this device, it basically is giving me it is a fixed path for this. Its current path is VMHPA33, so that's the adapter, and then you have the channel 0, then you have the target, so it's target 2. The targets start with 0, so it's 0, 1, 2, so this is the third target, and this is logical unit 0. So this is the way basically that paths are designated. First you have the HPA, then you have the channel, then you have the target, and then you have the actual logical unit. Now, instead of generic, let's change generic and let's look for round robin, and it will be interesting to see what we get here. So it's saying the generic PSP, let's look for round robin. Okay, now this device does not use the round robin path selection policy. So the command that we have just keyed in is ESX CLI storage NMP device list, and as you can see, for one of our storage arrays, which is canonical name, which is this, we actually have quite a few working paths. So if we actually count them, we can see 1, 2, 3, 4, 5, 6, 7, 8 paths. Let's see if we can recognize what this actually means, because we just looked at how paths are designated just a few minutes ago. So again, this is the VMHP833, which is our software SCSI, and then we have channel 1, we have the target 0, and then we have a LUN 0, and there are 8 paths basically going to this device. It's SATP is the VMware SATP Allure that we have just seen. Its path selection policy, the PSP, is VMware PSP round robin that we have just seen. These are some of the parameters that we have not seen yet. So you can see in the device configuration, the policy is round robin. The IOPS are 1000 before it actually switches over to the next path. The bytes that are sent down a certain path, when this is exceeded, then it goes down the next path, because it's a round robin policy. Use ANO 0, this one here, basically means whether to use the unoptimized path or not, and it's not going to basically use that. Number of IOs pending, number of bytes pending, usually one doesn't fool around with these. Really, the most often in terms of tuning, and again has to be done in conjunction with VMware support. This is where one would normally in practice perhaps do some fine tuning after basically all else fails. So what we're going to do is we are going to see how we can change the number of IOPS for this device. So in order not to have to key this again, I will basically select that, clear the screen. Now ESX CLI storage NMP PSP round robin, because we know our device uses the round robin multipathing method at this point in time. Device config, let's retrieve this first to verify it. Right click to put that back in there. As you can see, what we have is the 1000 we saw in a different way. The IO operation limit is basically 1000, and now we would like to actually set it. So we're going to step through the commands here. Instead of get, we will say set, and we'll hit the enter key, and you can see the various options that are actually available here. So we've already seen the -D for the device. This is how one actually changes the IOPS. What you do is, when you want to change that, you have to specify with the -T or the -- type equals, you need to have a string there. And really, value types are, you can either have bytes, okay, which will then set the trigger for path switching based on the number of bytes sent down a path. You could use IOPS. What that does is sets the trigger for path switching based on number of IO operations on a path. Or you can set it back to default, which sets the trigger for path switching back to the default values for this device. So what we'll do is we will change the IOPS, and from 1000 we will make the IOPS say I don't know, 1500 perhaps. So I finally have the device in there. I hit the enter key, and we have basically set that. And obviously the way to look at that would be to key in one of the prior commands that we have. One of them could be ESX CLI storage NMP device list, and we can look for the device that ends with a 19D0. And here we have the device, and as you can see, the IOPS has been changed to 1500. The policy is now IOPS, and it's not based on bytes anymore. The default policy was basically round robin, so I guess it would send an IO down one, and then next IO would go down the other in the round robin fashion. Now the policy is based on IOPS, and it'll switch only after 1500 IOPS have been done down one path. And this is one of the ways in which you can actually manipulate a given device. In this case, we were looking at this device that had the SATP of an Allure and asymmetric logical unit access, and the PSP for that was actually round robin. Now let's look at the web client and see what all this actually looks like. So keep in mind our storage array type is an Alua, and this is round robin. These items here you do not see in the GUI that I know of. So again, if you need to change these, this is where you actually have to do it, and it's not difficult to do, as we just saw. The working paths, of course, we all know are actually visible, and the path selection policy, obviously, one can change out on the GUI. So with that, let's switch over to the GUI. We will look for this disk here, the one that ends with a 19D0, and we'll see what this looks like in our web client. So now we are back in our web client. This is the host that we were working on the command line with, 192.168.0.201. We're looking at the storage. So let's look at the storage adapters first. So if you remember, the software SCSI adapter was VM-HPA33. Here it is, and that is its IQN. It has 17 targets, 3 devices, and 17 pads. So let's look at the various pads here. We have that for this, that is. So for the iSCSI device, there are all these pads that are active to the various target, which is also defined by an IQN, and we'll do this and much more in when we look at the iSCSI section of this course. So the runtime name is the VM-HPA33, the channel number, the target number, and the LUN number. So we're going to go back to the old-fashioned way of doing this, which would be essentially this. And here we have it, this disk here, the 19D0 is the disk that we were actually looking at and manipulating. Look at the storage devices, and yep, that's the disk that we were using. Its properties, so this is its identifier that we saw up there, 19D0, it's a disk, and that's the location, so it's located in /vmfs/devices/disks directory. It's a HDD, hardware acceleration supported, which means it is it has VAAI support. iSCSI, the owner is the native multipathing plugin. Now it gives us interesting other information about partitions and stuff like that. It's interesting to know it's available here, but we'll be looking at another tool as part of our section on VMKFS tools, how we can actually massage partitions as well, and obviously meant only to be done when things are in bad shape. Otherwise, normally one would use the GUI. Let's look at the various paths that are available to this. As you can see, there are many paths available to this, and they are all active. As you can see, they are all active, which means that it is not most recently used, so it's going on one path. All the paths are active, and we just changed the policy to IOPS, 1500 IOPS down one path, and then it would actually switch to the other path, but all the paths are actually active. Now in here, if we scroll down, we don't want to disable it. This is what we see here. The last path is channel 0, target 0, LUN 0. Okay. The next one is channel 1, then there's channel 2, 3, 4, 5, 6, 7. So from 0 to 7, it basically, that software adapter has 8 software channels through which it is getting to this target, which is on the device, on the storage array, and the LUN is LUN 0. If you select your device here, you can change the multipathing. So we had the VMware SATP Alua before. The PSP was VMware _PSP _RR. By clicking on edit multipathing, you can see that right now it's selected round robin, and that it's grayed out right now, but all the paths are actually active. Now if I click on this, and I'm sure you know this, select MRU, it'll select the most recently used path, and what will happen now is that all the other paths would be active and only one would become active for IO. So click on that again. As you can see, the most recently used one became the only one on which active IO is actually going on, and the other ones, while they're active, are not being utilized. So it's quite a waste of paths for which you have probably paid not to use them. And then of course, if you can make it fixed, but then you have to select which one you want to fix. So let's say suppose you have an Alua kind of a unit, and you want to make sure that the preferred path is fixed to the one that is optimized. So usually the lowest is usually optimized, so let's make that assumption. Anyway, in this case we will say, okay, I want to be the path selection to be fixed, and I want the traffic to go down this one. So I just click on that basically, and I click OK, and now the path selection has changed to fixed. When we edit multipathing again, we see that the one that we clicked is our preferred path, and you can see with the asterisk in the preferred column, that's where this is the path that would be used for active IO. So this is, if you want your traffic to go down a certain path because it is optimized in some way, this is how you actually select it. So we're back at our command line for the 192.168.0.201. Before we complete this video, there are a couple of other things I want to show you. So let's key in ESX CLI storage native multipathing NMP plugin NMP. I want to list the storage array types, and that is a list of storage array types and their default PSPs. What I want to do is I want to change it, because I have this symmetrics array, for example, this symmetrics array, and it has a policy of round robin, but I actually want to change it to say fixed for some reason. Okay, so this is how one goes ahead and actually changes the default PSP for a given SATP. The command is ESX CLI storage NMP namespace SATP set -s, the name of the VMW underscore SATP symmetrics SYMM, and we want to set the default PSP to say most recently used, which is VMware PSP underscore MRU, and that basically changes the default PSP for the SATP symmetrics is now MRU, and that is how that is actually changed. Let's clear the screen. And this is something you could do in real life as well. So the examples I'm giving you are advanced examples of things that can be done in real life. Especially, for example, the SVC, the IBM SVC, for example, there's a SATP that VMware has, but IBM also has a SATP, wonderful new capability, but it only works from their plugin, so you have to use their plugin in your pluggable storage architecture. This is how that is done. ESX CLI storage core plugin registration, and what we are going to do is to first list it, and these are the modules. So this would be the module name in lowercase. This is the actual name. It's of a type PSP, and this is a dependency. Let's pipe this to more so we can get a better idea. So the module name is this. The name of the, well, let's find one which has for left-hand network. That's the module name. That's the name of the actual plugin, and it's of class VAAI. So when you use when you want to specify and provide VAAI capabilities, you have to add and register this plugin. So the registration works like this. We hit clear again, so we have a clear screen up there. ESX CLI storage core plugin, storage core plugin registration, add, and let's just hit the enter key. So we have to specify basically the plugin class, the module name, and the plugin name. Okay, so we are going to make this up and say registration add. We will add something for say packed publishing. So add, we will specify the module, and we'll say the module is called PACKT pub, and what it is -p This is again, we call it the same name, hub, and the dash n specifies that this is a sat p, and we have just added this by doing a list. We can see that our plugin is right up at the top, and the plugin class is actually a sat p. Obviously, this is used when there are new modules to be added, because the storage array vendor has asked you to actually add this in there so that their product can be used by ESXi to the best of its capabilities. That's why we're doing this. And then of course we can also remove this easily as well. Let's take a look at the various options we have available. So ESXCLI storage core plugin registration, you can add a plugin module and register it with the PSA. You can list the modules registered with the pluggable storage architecture, and you can remove a plugin module with the PSA. So we are going to say remove, and then it's asking for the module name, which is pretty straightforward, -m. We called it packed pub. So this module for the packed pub storage array is going to be removed. And again, when you do the list of these plugins with the plugin registration list, you will see that as well. So with that, we have seen quite a few things. We have looked at our pluggable storage architecture. We understood what it was, the various plugins, the SAT-Ps for storage array type plugin, the MPPs, the multipathing plugin, and we just saw how we can add new plugins or register new plugins into our PSA and to manage its life cycle. We saw how, given a SAT-P or a storage array type plugin and the default PSP or path selection plugin that goes with it, we can actually change the default path selection to be something else. Later on, we'll see some other ones like mask path, which are used for masking, but we'll leave that for that video. We also then looked at how to recognize canonical names, NAA naming convention for devices. We saw the IQN for iSCSI devices and how that is actually formed, IQN dot, and then you have the year, month, and then the reverse name, so com.vmware, and then a colon, and then there is a bunch of characters that are actually then based on host name and some other attributes to actually create a complete equivalent of a worldwide name for an iSCSI adapter. Same thing for iSCSI targets and so on. There are different ways those names are actually generated. You can change them too if you wish. We explored how what the pluggable storage architecture is. We looked at generically how disks or devices and volumes are actually represented in ESXi. And then we looked at command line very extensively to understand how we can actually manage the pluggable storage architecture that is such a key component of vSphere 6. So with that, we come to the end of this video on the pluggable storage architecture. And the next video is configuring NFS 4.1 data storage, which I think you will enjoy tremendously, because this is a key new feature of vSphere 6. I look forward to seeing you on the next video.